To all those who devoted their lives to aviation. The Wings of Russia studio presents. Wings of Russia documentary. This aircraft was first shown in 1992. Thereafter, it was repeatedly demonstrated at various airshows. The armament arsenal was impressive. High-precision guided rockets and bombs capable of hitting targets in the air, on the ground, and at sea. It was not just an aircraft. It was a whole combat complex. This striking aircraft combines every function of a fighter, reconnaissance plane, a bomber, and attack aircraft. The route from inert attack aircraft of the mid-20s to this wonder weapon of the end of the century was not easy. Frontline aviation, the jet strike. After the Second World War, the Soviet Union started reduction of its army. This directly touched upon aviation. Imagine how difficult the task was. 36,000 of Il-2 attack aircraft alone were produced for the war. It was a mass demobilization. However, there was no complete transition to peaceful life. The Cold War caused new arms race. This time, weapons production went at a higher technical level and required incommensurably greater costs. In the beginning of the 50s, the Air Force of the USSR were divided into three types. The long-range aviation was designated to resolve strategic tasks. The military transport aviation was responsible for the troops and equipment relocation. While the frontline aviation acted in the interests of the ground forces, fight over the combat field, and in the close rear of the enemy. The frontline aviation is the most mass in both the amount and types. It included fighters, reconnaissance planes, bombers, and attack aircraft. Frontline bombers and attack aircraft will now become the subject of our close attention. These aircraft application specifics allow to call them the striking aircraft. It so happened that in 1956, half of this striking force suffered reorganization. The Soviet government decided to reduce its armed forces, and together with 63 other divisions, the 200th Striking Division was disbanded. Its aircraft joined scrapping. As before, the frontline bombers were assigned targets in the enemy's close rear, while the attack aircraft, with their heavy armor and inertness, stepped off the stage. Their place was taken by more faster fighter bombers. They were now supposed to support forces right at the battlefield. At first, regiments of the fighter-bomber aviation were equipped with MiG-15. Later on, MiG-17 appeared. This aircraft left MiG-15 behind in terms of flight characteristics. Armament of the MiG-17 striking variant was reinforced. Rockets were added to the 3 existing cannons. Bombs could also be suspended. The use of pure fighters for such tasks was, of course, a temporary measure. From the beginning, these aircraft did not comply with the striking aircraft class. However, what the militaries liked in them was their speed. MiG-15 made a good showing in the Korean War. In fact, speed seemed to be half the battle. Designers, based upon achievements in the engine's construction as if reveled in the discovered abilities, joined the race for speed. Together with the fighter bombers, the frontline bombers had to be made faster. In the second half of the 50s, the old subsonic Il-28 had no chances to penetrate the enemy's air defense. Several new aircraft were offered to substitute the Ilyushin's machine. The supersonic Il-54 made in the Ilyushin Design Bureau was a sequel of the Il-28 concept. The Tupolev's Tu-98 frontline bomber had almost the same flight characteristics. But the winner in this competition was Alexander Yakovlev's aircraft. The first test pilot of this aircraft was Valentin Volkov. The two-seat Yak-28 became the first supersonic bomber entering service for the frontline aviation. This aircraft could carry up to 3 tons of bombs. But to hit the target was quite another task. Capabilities of Yak-28 in this respect were limited. The navigation aiming equipment just started its climb to the top of perfection. Well, Yak-28 was being created as a tactical nuclear bomb carrier in the first place. The future war in general was assumed as a nuclear war, and accurate bomb dropping was not decisive. The main thing was that Yak-28 could reach a speed of 1900 kilometers per hour. Apparently, a high-speed requirement for striking aircraft was rather disputable. Yes, for pure fighters and long-range bombers, high speed was probably needed, but not for the frontline aircraft. First of all, due to a minor action radius, they had no place to exceed Mach 1. Secondly, it was ridiculous to approach the target and attack it at such a speed. The aiming equipment of that time could not serve such a purpose, while the pilot can actually see the target only at a speed of not more than 600 kilometers per hour. However, a supersonic speed in those years was almost the main demand. By that time, a leader in the high-speed aircraft development and fighters in the first place appeared in the USSR. It was the Artyom Mikoyan's Design Bureau. It made a sound representation of a number of its aircraft of this type. However, when the Air Force ordered itself a new fighter, the Sukhoi Design Bureau became the winner of a latent competition. Its Su-7 was even put into serial production. However, some other fighters was commissioned for service. Su-7 was too heavy as a fighter. Therefore, it was turned into Su-7B, a fighter bomber. Bridges, ferries, engineering constructions, enemy's combat equipment located in the frontline area were among the potential targets. Su-7B, capable of carrying significant payload, including tactical nuclear bombs, started to fill Air Force units in large quantity. This was happening on the verge of serious geopolitical events. Two worlds, two systems confronting each other in the Cold War approached a dangerous edge, the Caribbean crisis. And having overcome it, state leaders came to an understanding that it is impossible to use nuclear weapons. Even if only one counterparty uses it, consequences would be catastrophic for everyone. Such understanding led to a fundamental revision of military doctrines of practically all states involved in big politics. Today, in the application of the fighter-bomber aviation capable of carrying nuclear weapons, the main accent is made on the use of conventional weapons. By the end of the 60s, Su-7B served in 25 air wings of the Soviet Air Force. Those aircraft made the basis of the frontline aviation. As compared to aircraft of the previous generation, Su-7B seemed to have an apparent advantage. Its speed was over 2,000 kilometers per hour. But what was interesting, at one of the maneuvers, the supersonic Su-7B was less successful than its subsonic but more maneuverable predecessors. The practice itself was cooling down the speed fans. Apart from low maneuverability, this striking aircraft had other drawbacks. Due to weak navigating equipment, those aircraft could be efficient only at daytime and only in good weather. Besides, Su-7B had a high landing speed and an insufficient combination of weapon load and range. But most important was that the front and downward visibility from the cabin was very poor. What a default for an aircraft aimed at ground targets. On the other hand, foreign analog fighter bombers like F-105 Thunder Chief had almost the same characteristics and similar defaults. However, navigating equipment of American aircraft was better. They also had weapons control systems with a radar device. The national radio electronic industry did not have such developments, and Su-7B had no radar. A characteristic feature of those times was the aircraft's cross-country capability, making it take off and land without any prepared strips. The aircraft with this purpose was equipped with a wheel and ski landing gear. No matter whether it was mud, slush, or a breakup season, the aircraft would take off. Rockets, boosters helped to do that. Just the outlook of such a roaring monster seems to embroil any enemy. Unpretentious and solid, Su-7B was operating not only in the USSR but in many other countries. It had to show its combat qualities in real action. It was used in the Arab-Israel wars and in the Indo-Pakistan conflict. There was a two-seat trainer version of this aircraft. Such dual-control plane trained thousands of future frontline aviation pilots. Su-7B was the product of its time when technical and aerodynamic perfection was yet out of discussion. However, its wide exploitation allowed to make a qualitative breakthrough in the development of the striking frontline aircraft. Su-7B laid the basis for a whole family of fighter bombers. On July 9, 1967, an air parade took place in Domodedovo near Moscow. Besides regularly produced combat aircraft, prototypes of the brand new aircraft were shown, which several years later made the basis of the Soviet Air Force. Among them was a prototype of the future Su-17, the one-seat fighter bomber developed on the basis of Su-7B. The new aircraft had one peculiar technical feature, a variable sweep wing. Look, at takeoff, the wing is straight. Now the wing is swept. The wing becomes one more straight at landing. The rage toward variable sweep wing in those years was not idle. With a slight complication and changing of the layout, it gave a lot of advantages. If we compare characteristics of the new Su-17 with the old Su-7B, we shall see improvements in all parameters. The landing speed significantly dropped. The takeoff and landing run became twice shorter. The variable sweep wing allowed to optimize the flight mode, which made a positive impact on the range. By the beginning of the 70s, the unreasonable race for speed stopped. For the fighter bombers, more important became not the altitude speed characteristics, but the radius of action, ability to base on short, unprepared airdromes, impressive weapon load, and efficiency in hitting ground targets. Fighter bombers were more becoming attack aircraft rather than just fighters. Such tendency could be well followed in the development of the Su-17 family. Su-17 was commissioned in 1970. It was followed by Su-17M, which thrust-to-weight ratio was increased due to a more powerful engine. This, in its turn, allowed to bring up the weapon load. 3 years later, Su-17M2 went on tests. It had a slightly longer fuselage and a new content of the aiming and navigating equipment. The air-to-surface class weapons were expanded to include guided missiles with a laser targeting system. Su-17M3 became next in a row. With this model, the Sukhois practically resolved the problem of poor visibility inherited from Su-7B. With this purpose, the nose was slightly bent down. Besides, the fuel reserve was increased. Su-17M4 fighter bomber became the top of the evolution. Its production started in 1981. Lesser demand for speed characteristics brought to weight saving and simplification of the airframe. In result, the weapon load increased to 4 tons. This aircraft had almost no features of a fighter. It was a real light bomber. For the aircraft of this type, one of the main bomb-dropping technique was at diving. Efficiency of such method was known from the days of the Second World War. New tactics was mastered. For example, pitch-up bombing. At diving, the aircraft goes down. Instead, at pitch-up bombing, it climbs. When the bomb is detached, the aircraft quickly flies away. The bomb continues to gain altitude for some time and then vertically drops on the target. Such technique, with certain aiming complexity, has a number of advantages. It allows the attacking aircraft not to enter the air defense zone. Besides, it gives the aircraft a chance to retreat at a safe distance from the explosion. The latter condition is important at the use of such powerful charges as a tactical nuclear bomb. To help mastering all these combat applications, a two-seat Su-17 combat trainer version was developed. Almost 1,200 aircraft of the Su-17 family was built in 20 years. It should be outlined that in those years, Su-17 fighter bomber was not the only one in its class. When Brezhnev came to power in 1964, the military budget became to swell. Money for the new aircraft could be obtained with no difficulties. That's why, together with a large-scale program of the Su-17 family modernization, there appeared the possibility to build MiG-27, another aircraft of similar designation. To a greater extent, both aircraft were no competitors. Appearance of the two aircraft was no accident. They were required long ago. Experience was gained, quantity demanded transition to a new quality. Deficiencies of the striking aircraft of the first generation and the way toward improvement was clear. Besides, revolutionary changes in the aviation armament occurred. Air-to-surface missiles reduced their weight and bulkiness, and could now be well suspended on light fighter bombers. Just like the types of armament, the concepts of the striking aircraft application in those years changed impetuously. When MiG-27 production was just started, the dominating application was to approach the target at high speed, hit it in one pass, and withdraw from attack. The minimum stay in the target zone significantly reduced the risk of destruction. The speed provided viability. Later, the high-speed attack concept gave way to another idea. The speed was slightly victimized in favor of weapons precision. Just like Su-17, MiG-27 was not made from scratch, but on the basis of a preceding aircraft. At that time, MiG-23 was being developed in the Mikoyan Design Bureau. The striking aircraft was assumed to be made on its basis. Since number one requirement was visibility, the Mikoyans went for a serious plastic surgery. Thus, MiG-23B appeared. The striking version aircraft acquired a duck nose. Such form could not hold a radar, but the aircraft of such a designation did not need it. Instead, a compact missile guiding set was placed there. To keep the center of gravity position, the weight of the detached radar was compensated by armored shields placed on both sides of the cabin. Further modification of the aircraft was mainly done with the account of its application. Air intakes were optimized to work in a subsonic mode. Instead of a fighter cannon, there was a 6-barrel cylinder type cannon. The weapon load was increased from 3 to 4 tons. Such aircraft was already called MiG-27. In 1974, this aircraft was first taken into the sky by test pilot Valery Minitsky. This aircraft had a lot of new technical solutions, thanks to which the most complicated combat tasks could be performed in the entire range of altitudes, including critical load altitudes and supersonic speed. It was a good and required aircraft. It was nicknamed Balcony for the perfect visibility. Indeed, the pilot did not see the nose of the aircraft. Instead, the battlefield was clearly visible. The powerful 6-barrel cannon deserves a separate attention. There was even the concern that the recoil may stop the aircraft in the air. This, of course, did not happen. However, at first, the cannon used to impact not only the target, but the aircraft itself. Shooting produced gas dynamic disturbance that troubled the engine. The aircraft equipment and suspended weapons suffered from vibration. The aircraft was significantly modernized when it was equipped with the Caira laser aiming system. Such modification turned out to be very expensive, but this aspect did not bother the militaries much. The aircraft could now perform with high precision in any weather, day and night. Caira allowed to detect targets at greater distance than before, without entering the enemy's air defense area. Besides, this gave not only a passive chance to escape means of air defense, but actively attack them. The aircraft's arsenal included Ha-27 missiles aimed at destroying enemy's radars. MiG-27 was also equipped with heavy Ha-29 missiles, which were used to destroy concrete runways and reinforced structures. The first reaction toward improved MiG-27 in the wings was normal: abruption. Examination and mastering of a new highly intellectual equipment was a hard labor. Mikoyan experts helping Air Force detachments to introduce the new aircraft almost burst into tears at seeing how technicians dealt with the high-precision equipment. Was there any use making such high-precision systems? However, the aircraft was soon appreciated for its capabilities. The combat efficiency as compared to the first modifications was more than twice higher. Pilots wondered why the aircraft was not renamed, since it was so different. Many countries purchased MiG-27. The major importer was India. It did not only buy but arranged licensed production of the aircraft, which was issued under the name of Bahadur, the Brave. With continuous upgrade, MiG-27 has been still serving in the Air Force of India. The requirement for such an aircraft is dictated by stable instability in the state of Kashmir, a long-lasting reason of dispute with the neighboring Pakistan. Although MiG-27 fighter bomber was not specifically made to reach the target at low altitudes, such drills took place. And if the breakthrough was massive, it was successful as a rule. Target approach at low altitude allowed to stay unnoticed by the enemy's radars, and therefore to minimize the risk of being hit and carry out the combat task. High speed added to invulnerability. But a fighter bomber has nowhere to reach it. The targets are nearby at the front line. A frontline bomber, sometimes flying thousands of miles over the enemy's territory to the target, is something else. Here, the supersonic speed combined with the low-profile flight would be right to the point. Such requirements made the basis for the new frontline bomber, Su-24. In the course of its development, this aircraft underwent significant changes. It was started as a modification of the Su-15 fighter. Reduction of the takeoff range was at that time thought to be an important task. Therefore, the aircraft was equipped with additional lift engines. They were required only at takeoff and landing. It was absolutely useless to carry them as a dead weight at long distances. Pluses were covered by minuses over and above. But such conclusions did not come at once. The next stage layout included the lift engines again. The new aircraft was identified as T-61. The T index meant that there was a delta wing. Then wings had downward endings, or as designers called them, the flippers. They provided the aircraft with a more stable flight. The fuselage had square section with sharp edges, just like the leading Western aircraft layouts seem to have. The prototype was decided to be shown at an air parade in July 1967. However, due to technical problems, the aircraft did not appear. Since it was too late to change this scenario, a painted black Su-15 flew accompanied by the words of "a new Soviet fighter bomber." As it was already said, the future Su-24 design did not escape influence of the Western aircraft. One of them was the American F-111 fighter bomber. It had several technical solutions implemented later on Su-24. For instance, the variable swept wing. Substitution of the delta wing for a variable swept wing provided the aircraft with perfect takeoff and landing characteristics, which allowed to give up the burden of the lift engines. This also allowed to optimize flight parameters at different altitudes. The low-altitude flight required an additional radar in the navigation system. Besides the pilot, a navigator was added to the crew. Like in F-111, they were sitting side by side. The problem was that the production term did not comply with the requirements. The aircraft was made in just 26 months. The first flight was performed by test pilot Vladimir Ilyushin in January 1970. The aircraft was urgently put into series, however, intensive refinement went on for several years. The price for the rush was very high. 10 aircraft were lost during tests. 8 pilots ejected and survived, while 13 test pilots and navigators died. No other aircraft of that design bureau brought so many losses. To create a supersonic low-flying aircraft turned out to be a super complicated technical task. The Sukhoi Design Bureau employees confessed that it was the most difficult aircraft. But it turned out to be an all-time and all-weather menacing weapon. The terrain following flight occurs at a speed of 1,300 kilometers per hour. The range is over 2,000 kilometers. 7 tons of combat load. Su-24 was commissioned in 1975. This aircraft had no match as to the weapons amount and list. The customer required the aircraft to have as much as possible on board. Bombs, missiles, rockets, radio electronic equipment, a total of almost 400 stores. Such huge arsenal required to put means of control, 160 push buttons and switches. It was not easy to master. Divisions started in the air regiments. Some crews specialized in bombs utilization, others in missiles. After some time, Su-24M, an improved modification, was commissioned. Apart from all, this aircraft was equipped with an in-flight refueling probe. Now capabilities of the Su-24 frontline bomber were close to the potential of the large, long-range bombers.
412 работу закончил. Режим 2. Понял.
In August 1964, the Vietnam War started. Several years later, the fighting parties acquired certain experience. This meant that powerful, fast attack aircraft was not always efficient against minor, well-disguised targets. A slower aircraft was needed, but it would become vulnerable. Such tasks could be resolved through armoring. It was a return to the idea of an attack aircraft. Works in this direction were started in the USA. Information on the American aviation activities in Vietnam was coming continuously. The Soviet designers also came to an understanding that the attack aircraft were rejected erroneously and that sooner or later, those slow armored aircraft will have to be recalled. Thus, in the beginning of 1968, the Sukhoi Design Bureau secretly started development of the future Su-25. The new defense minister, Andrei Grechko, approved of the novelty in 1969 and the works went on officially. In order to comply with the formalities, a tender for the new attack aircraft was announced. Design Bureau of Sergei Ilyushin, which attack aircraft became famous in the Great Patriotic War, got involved. Right after the war, Ilyushin developed a jet attack aircraft. This time he offered a version of that old-time aircraft. In the meantime, works on Su-25 went on with variable success. The militaries offered new requirements, requiring, for example, the aircraft to be supersonic. Then everything calmed down for several years. The Sukhoi Design Bureau started to build the aircraft all by itself, based upon its own understanding as to how an attack aircraft should look like. The layout was simplified for the reasons of reliability. The cockpit was depressurized since the attack aircraft did not have to climb high, while perfect visibility facilitated the target detection task. The first flight of this aircraft took place on February 22, 1975. The banquet in honor of the first flight was attended by twice hero of the Soviet Union, Aviation Marshal Alexander Yefimov. During the war, he flew on the famous Il-2 attack aircraft. Now the hero proposed a toast to the resurrection of the attack aviation. But the toast was not enough. Su-25 did not join the Soviet Air Force. The Air Force commander, Pavel Kutakhov, paid little attention to the new attack aircraft. He liked MiG-23 more. And only when the Poles turned to Brezhnev asking him to let them produce Su-25, Brezhnev wondered why he did not know anything about the aircraft. And that's when it all got rolling. It was in summer 1976. Later on, Ilyushin also introduced its attack aircraft. It was called Il-102. But the deal was already done. The niche was taken by Su-25. The first serial-produced aircraft left the factory in 1979. It was immediately sent to Afghanistan. For Su-25, Afghanistan became the main examination. The attack aircraft did not have big range, however, it could carry a significant load of bombs and rockets on numerous pylons. For its peculiar front view and the stockade of pylons, the aircraft was nicknamed the Crest. Throughout 9 years of its war service, only 23 aircraft went lost out of a total of 60,000 combat flights. In terms of viability, Su-25 was 5 times better than the other aircraft. Su-25 was equipped with efficient survival measures in case of a Stinger hit. Tests results were completely confirmed by combat implementation in Afghanistan when aircraft used to return on one engine and with a pierced fuel tank. It gained stable reputation as the most viable aircraft. Fuel tanks sustained direct hits. During combat activities, not a single fuel tank explosion incident was detected. Not a single pilot was killed inside the armored cockpit. Armor protection of the most important units of the aircraft and its crew is the subject of the aircraft designer's pride. This aspect was specifically analyzed from the beginning. Hundreds of tests on the armored body were conducted at the test field. It underwent unmerciful firing from different types of weapons. Research helped to bring this part of the layout to perfection. Other frontline aircraft were sent to Afghanistan as well. Although MiG-27 was used there only at the end of the combat activities. Su-17 served in Afghanistan from the beginning and in a large quantity. Designed for the plains of Europe, these aircraft did not match well the mountainous terrain. It was hard for them to maneuver in the bottlenecks, and their sophisticated targeting equipment was practically useless in search of a low observable counterparty. The way out was in the unsighted carpet bombing. Starting from 1985, more bombs were thrown at Afghanistan in 1 year than in the entire Great Patriotic War. Local specifics influenced the work of aviation a lot. In the hot high mountain environment, the thrust-to-weight ratio dropped. Pilots had to either increase the takeoff run or reduce the payload. But still, Su-17 was worthy. Reliable and enduring aircraft flew even in sandstorms. Su-24 frontline bombers found their job in the war as well. Its range was enough to work over Afghanistan based in the Soviet Union. Bombing was performed from high altitude, not too much sighted, but the bombs were of a larger caliber, up to 1.5 tons. Sometimes a daily bomb spending for a Su-24 wing reached 250 tons. Su-24 was trouble-free in that war. The test pilots' lives given away proved not to be in vain. No losses of this aircraft occurred. By the end of the 80s, the basis of the USSR frontline aviation was formed by Su-17 and MiG-27 fighter bombers, Su-24 frontline bombers, and Su-25 attack aircraft. Aircraft capabilities were assessed as quite sufficient for the defense of the country. But the potential enemy continued to improve its aircraft, while the Soviet Union could not afford itself lagging behind. Equipment appreciation tendency did not allow to fund development of a number of new aircraft. However, creation of a single multifunctional aircraft combat complex seemed to be quite realistic. Such aircraft could substitute all other machines in service. High speed and maneuverable at the same time, with a high payload and a big range, such contradictory requirements could be resolved by achieving a certain technical level. This kind of aircraft was started in the Sukhoi Design Bureau in the beginning of the 80s. No wonder that the serial Su-27 was taken as the basis. It was created upon an integral scheme which has an enormous potential for modernization. The new frontline aircraft was identified as Su-34. Scientific achievements in aerodynamics allowed not to implement variable sweep wing on this aircraft. For better aerodynamic characteristics, it was equipped with additional front canard surfaces. This provided the aircraft with stability at all speeds and altitudes, in particular on critically low altitude. The characteristic feature of the integral scheme, almost ideal from the aerodynamic point of view, is its significant internal volume. They allow easy allocation of different equipment in the aircraft and increase its fuel reserve. More than that, the aircraft is equipped with the in-flight refueling system. The flight range amounts to 7,000 kilometers with one refueling. Such figures can already be attributed to long-range aviation. As to equipment, it is managed by several onboard computers. More capabilities brought more weight. Su-34 reaches 45 tons with the maximum combat weight. This led to improvement of the landing gear, where the main undercarriage legs were equipped with two-wheel bogies. The cabin entry is unusual. It is located in the niche of the nose gear. The cabin itself is interesting. It is spacious, comfortable, with perfect visibility. Like in Su-24, the crew sits side by side. This facilitates pilots' interaction. Rest and food taking during a multi-hour flight is envisaged. Su-34 armament is impressive. Various missiles and bombs to destroy ground and sea targets. This arsenal includes air-to-air missiles capable of destroying highly maneuverable targets. From its predecessor, Su-27 fighter, this aircraft inherited wonderful piloting characteristics. If before the term fighter in the name of a striking aircraft was more a tradition rather than reality, now it was indeed a fighter-bomber. By the beginning of the 90s, when the aircraft was ready, Air Force already experienced difficulties in buying these machines. Promotion efforts brought some results. A decision to put it in production was taken. It was started in Novosibirsk. Simultaneously, all one-engine attack aircraft were decommissioned irrespective of their resource. MiG-27 and Su-17 were announced unreliable and were sent in custody. The way for Su-34 seemed to be clear. The Air Force could not remain without these striking aircraft. But those were the cloudy 90s. It was easy to decommission one type of aircraft. It became very hard to substitute it with another. Su-34 was not then commissioned. In spring 1995, the new aircraft was shown in France at the Le Bourget International Air Exhibition. In the time of the USSR, only civil aircraft was taken there. New times brought new abilities. In Paris, Su-34 was exhibited as Su-32FN. The two letters were translated as Fighter Navy. This made the dubious future of the aircraft still more unclear. What about the Western aircraft of the same designation? In Europe, the main attack aircraft was Tornado, a two-seat supersonic fighter-bomber jointly made by several countries. In the USA, there was F-15E, a two-seat supersonic fighter-bomber designed on the basis of a fighter. It was commissioned by the U.S. Air Force in the second half of the 80s. The F-15E armament differed a lot from that of a fighter and was at maximum adapted to work on ground target. Both aircraft undergo continuous upgrade. As to Su-34, One can state a lot about the fact that this aircraft had no match in the West. The real point was that the Western aircraft were already in service. So what's now? Who, if necessary, would support the soldier at the front line? As of the beginning of 2008, the picture was the following. The most mass frontline aircraft in the Air Force of Russia today is Su-24. Gigantic capabilities of Su-24 designed in the heat of the Cold War have been optimized for the deep penetrations into the enemy's rear and are somewhat excessive for the battlefield. MiG-29 and Su-27 fighters can also attack ground forces, but they do this not as efficient as the specialized aircraft. The multi-purpose Su-34 is so far in plans. Several aircraft have been given to the Lipetsk Training Center. Other machines have been thoroughly tested in the Air Force State Test Center. There, in mid-90s, Su-39 underwent tests. This aircraft is an all-weather modification of the Su-25 attack aircraft. Su-25 itself, a viable, unpretentious, well-armed, remains the main aircraft of direct ground forces support. And of course, helicopters. Today, one cannot imagine a battlefield without these rotary wing machines. Time changes, together with the changing priorities and combat concepts. Soon, we might see a completely different aviation of different ground forces support. Time will show how it would look like.